Okay, in this lecture video, we're going to start looking at Lewis structures for molecules with covalent bonds. And the easiest example to start with is that for one of our diatomic elements, which is hydrogen. So hydrogen, if you look on the periodic table, has an electron configuration of 1s1. It's got one electron. So if I were to draw Lewis dot symbols of that, I would have one hydrogen with its single electron, which is a valence electron since it only has one, and then the other hydrogen. So each one of these hydrogens is a 1s1. And so when we're talking about covalent bonding, we're talking about the sharing of two electrons in a bond between atoms, and each atom brings one electron to the table. So each one of these hydrogens here has an electron to donate to the covalent bond. So now if I want to show that covalent bond, I could show it a few different ways. I could draw the hydrogen and show two electrons as dots between the atoms. Or I could also show that instead of showing the electrons as a pair, I could show them using a straight line. So when we do that, this line right here represents a shared electron pair. So in this case now, each one of these hydrogen atoms here needed one electron to fill its valence shell, because remember, since it's n equals 1, all it has is a s subshell, which can contain a total of 2 electrons. So here, when we look at this hydrogen, if I wanted to count the electrons available, it would have both electrons in this bond between the two hydrogens available to it, and the other hydrogen would also have both of those electrons. So in each one of these cases, each hydrogen now has 2 electrons, that it's getting one of them by sharing through a covalent bond. So the next example we'll look at then is ozone. So ozone has the chemical formula of O3. And so if I were to look up oxygen on the periodic table, it would have the electron configuration 1s2, 2s2, 2p4. And so when I look at this, I see that the valence shell would be n equals 2. And in that valence shell, there are a total of 6 electrons. So 6 electrons in the valence shell. So oxygen has a total of 8 electrons, 2 of them are core, and 6 are available to form bonds. So now if I were to draw the Lewis dot structures, or the Lewis dot symbol for each one of these oxygens, so there are going to be 3 oxygens in our structure. Each one has 6 valence electrons that I need to put on my structure. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if we look at this, we can see then each one of these oxygens has space available to form 2 bonds, because it needs 2 electrons to complete its valence shell, which would take it to a total of 8 electrons to complete the shell. So we have to do that through chemical bonds, and we have to look first of all at how many electrons are actually available to go on our structure. So if we've got 6 valence electrons for each oxygen atom, and there are 3 oxygen atoms total, then that means we have a total of 18 valence electrons that are available to be shared amongst these oxygens to get each one of them up to a total of 8 electrons in their valence shell. So there are a couple of ways that you could do that, and I'll give you guidelines for how to draw these structures in the next video. But I could do it like this, where I've got some electrons in bonds between atoms and some electrons existing by themselves as what we call lone pairs. So I could draw it like this, or I could draw it like this. Slightly different. So what we have here now, in order to get each oxygen to have valence electrons equal to 8, I had to use double bonds. So right here, this is a double bond between the two oxygen atoms, and each line represents 2 electrons shared. So there are a total of 4 electrons shared between those 2 oxygen atoms. So we can have single bonds, we can have double bonds, and sometimes you'll even see triple bonds. So let's count then how many electrons are available to each one of our oxygen atoms in this structure. So if we look at this first one, there are 2 4 electrons that are lone pairs. They're by themselves, so they only belong to that oxygen. And then this oxygen atom also has access to these 2 and these 2. So that's a total of 8 electrons for this first oxygen atom. Then if we look at the second oxygen atom, since these electrons are shared, it has access to these 2 electrons and these 2 electrons. That's 4, 6, 8. So that oxygen also has a total of 8 electrons available to its valence shell. And then if we look at our last oxygen, it gets access to this pair that's shared in a bond. So that's 2, 4, 6, 8. And if you add up all of the electrons on this particular structure, you should get a total that we have 18 electrons shown on the picture, which was the number of valence electrons that we had available in the first place. So in these Lewis structures with covalent bonds, sometimes you'll see multiple ways to draw the structure. So for example, we have this version or this version, and either one of them is correct. In fact, both of them are correct together. And sometimes you have to use multiple bonds in order for each oxygen to meet 8 electrons in its valence shell.